Hello everyone and welcome to the discrete random variable. In probability, the outcomes of a random experiment are in general non-numerical. So to analyze these outcomes, we assign numbers to them. Okay, and this leads to the concept of a random variable. All right, so we will talk about the random variable and what is the meaning of discrete random variable. All right, what is a random variable? A random variable is a function that assigns a numerical value to each outcome in the sample space. All right, so it's kind of a function. It assigns a number like 1, 2, 3, 0 to each outcome in the sample space. I will give you an example in the next slide. In general, we use capital letters for the random variables. For example, capital X, capital Y, capital Z. Those capital letters denote the random variable. And we assign a small letter to the specific values of the random variable, okay? For example, our random variable X could be number of heads or number of tails. But the values of that random variable could be 0, 1, 2. We say small x, lowercase, equals 0 or 1 or 2. So this is the meaning of capital letter and the small letter. So capital letter is the random variable, and the specific value of that random variable we use lowercase letter, such as small x, small y, and small z. All right. Example of a random variable. So we have flipping 2 coins or toss a coin twice. And as you know, the sample space is the set of head, 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 tail, tail, head, and tail, tail. And we define a random variable x to be number of heads, right? So number of heads in this case x, the random variable x equals number of heads. So in this case, number of heads could be 0, 1, or 2, right? Because here, if you look at the sample space, we have head, heads. So in this case, we may define something like this. Maybe a small table. Like these, the outcomes, right? And here, number of heads. Now, if the outcome is head, head, in this case, number of heads equals 2, right? Because we have head, head, so number of heads equals 2. If the outcome is head, tail, in this case, number of heads equals 1. And if the outcome is tail, head, number of heads equals 1. And the last possible outcome is tail, tail. In this case, number of heads equals 0. So the values of that random variable x are 0, 1, and 2. 0 when we have tail, tail. 1 when we have one head, so it could be tail, head, or head, tail. And 2 when we have head, head, which means 2 heads, right? So this is the meaning of random variable. All right, so there are 2 types of random variables: discrete random variable and continuous random variable. The example that we discussed in the previous slide is an example of discrete random variable. All right, and we are going to focus in this presentation on the discrete random variable. A discrete random variable take on a finite or countably infinite of values. So these values are obtained by counting. So if we can count them, we call it a discrete random variable, such as number of heads when you flip a coin, number of students absent from class, number of defective items in a batch. So as you see, we can count them like 0, 1, 2, 3, 4. This is an example of discrete random variable. If we have an interval such as, for example, the waiting time of something, like the time could be like the interval from 0 like to 1 hour or 0 to 60 minutes. So the time is an example of a continuous random variable, okay? This is not our talk for today. So in this presentation, we focus on the discrete random variable where we can count the values. All right, so a probability distribution of a discrete random variable assign a probability to each possible values of x. All right, so for each value of x, we give a probability. This is called a probability distribution. All right, so, and it has two properties. Number one, the probability is between 0 and 1. Number two, the sum of the probabilities equals 1. All right, so I will show you an example of probability distribution in the next slide. All right, so this is a very basic example. Roll a fair die once. Let x equals the outcome of the die. So as you see here, so the values of x are all of the possible outcomes, and this is our sample space, right? 1, 2, 3, 4, 5, 6. Those are the possible outcomes. Now, what is the probability of each one? Probability of getting 1 is 1 over 6, right? Because you have 6 outcomes, and of getting 1 is 1. Probability of getting 1 is 1 divided by 6, 1 divided by the total, right? Similarly, probability of getting 2 is 1 over 6. Probability of getting 3 is 1 over 6. So as you see here, we have x and probability that the random variable x equals a small x. So this is called probability distribution. There is another example. A fair coin is tossed 3 times. Define the random variable x as the number of heads. So here, you have to determine your random variable. You have to understand the random variable. So in this example, the random variable x is number of heads. All right, and determine the probability distribution of x. So we have a random variable x, which means number of heads. And the experiment is tossing a coin 3 times, right? All right, so before we start, before we calculate the probability distribution of that random variable x, we have to think about the sample space. What is our sample space? All right, so in this example, our sample space, maybe you can do something tree diagram. For example, you may, the first time you may get head or tail, right? The second time you get head or tail, and head and tail. And then we have head, tail, head, tail, head, tail. So those are the 3 times, right? So our sample space is head, 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 right? Head, 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 and then head, head, tail, then head, tail, head, and then head, tail, tail. Those are the first part. Then we have 4 more. Then we have tail, head, tail, tail, head, tail. Then we have tail, head, tail. then we have head, tail, head, and the last one is, I'm sorry, I did a mistake. So we have tail, head, head, tail, head, tail, 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 head, tail, tail, head, and the last one, tail, tail, tail. This is our sample space, and as you see, the sample space consists of 8 elements, right? Now, the random variable x is number of heads. So in this case, number of heads could be 3, or 2, or 1, or 0, right? So the best way to think about this is creating this table. So you give the letter x here, or y, or yeah, we define capital X. So the values of that random variable x is small x, so small x. The values of x are, because number of heads could be 0, 1, 2, or 3, right? Now, the question is, what is the probability distribution? So probability distribution is here, is probability of the random variable x equals small x. Now, what is probability of getting 0? 0 means number of heads equals 0, and it happens in only one case when we have tail, tail, tail. In this case only, we have no head, right? So it's 1, right? So 0 happens when we get tail, tail, tail. So probability of tail, tail, tail is 1 over 8, right? Now, what is probability of x equals 1? X equals 1 means number of heads equals 1. All right, number of heads equals 1 happens in, I guess, 3 cases. This is number 1. We only have 1 head, and there is 1 head here, and there is 1 head here. So we have 3 outcomes, right? So 3 divided by 8. Similarly, what is probability x equals 2? 2 heads. 2 heads happens here. This is the first one, the second, and the third. So similarly, it's a 3 divided 3, 8. And x equals 3 means number of heads equals 3 is the first one here. So it's 1 over 8. So this is a valid probability distribution, because if you look at each value here, each fraction is between, the fraction is between 0 and 1. And if you calculate the sum of the probabilities, if you calculate the sum of those 4 fractions, the sum is 1. And this is exactly our definition. So if you go back to the slides here, so the first condition, probability that, sorry, because the writing covers that, but if you look here, the probability satisfies that between 0 and 1, and number 2, the sum of the probabilities equals 1. All right, so this is the definition of random variable and especially discrete random variable. Okay, thank you very much.